Hi everyone, today we're going to talk about a brief discussion of black holes and primordial black holes. And first, what is a black hole? We have known the basic concept of a black hole. So, as we have learned before, any celestial body has an escape velocity. If we reach this speed, we can run away from the object. However, what if the gravitational force of this object is very large, and the escape velocity is even faster than the speed of light? According to the theory of relativity, no speed can exceed the speed of light. That means no matter how hard we try, we can't escape. In other words, the concept of black hole is related to escape velocity, so it doesn't have to be very big to be a black hole. In the American drama Big Bang Theory, we mentioned that Sheldon wanted to create a very small black hole to test his string theory. And this black hole was formed by compressing down 20 micrograms of gold into a very small volume. If Sheldon really misses, the type of black hole will be our today's main topic, the primordial black hole. Then we have to ask 4 questions. First one, how big can an object be considered a black hole? Second, experimentally, we can obtain a black hole by compression, but how did a black hole in nature come about? And third, what happened to such a black hole later? And fourth, will a black hole near Earth affect the Earth? With these questions, we are going to talk about Hawking made a detailed mathematical argument for this matter in his 1971 paper, Gravitationally Closest Objects of Very Low Mass. In this paper, he calculated that it would only take 10 minus 5 grams of matter, roughly equivalent to a comb of bacteria. If it's small enough, it can coalesce into a black hole. This is a primordial black hole. So, why would the universe make such a small and heavy thing, and where does such a huge force come from? As far as research goes, we can only trace this force to one source, the Big Bang. It has been mentioned before, the first second of the Big Bang, there were no celestial bodies in the universe. There was only a mass of chaotic particles like the picture showed on the left side. They were rising and falling due to quantum effects, unevenly distributed, dense in some places and sparse in others. Hawking proposed in places where the density is blown to the maximum, it could collapse into a primordial black hole. So, where does this primordial black hole go later? Astronomers believe that this is the initial form of dark matter. There are 2 main theoretical explanations for dark matter. The first one is weakly interacting massive particle. The dark matter will be a type of matter that we haven't discovered. They can pass through light, but they don't interact with light at all, so you can't see it. The second type is massive astrophysical compact halo object, so-called the meteor. This refers to objects that are very massive but don't emit any light and are invisible. Black holes fit perfectly to definition. Primordial black holes, which we can also consider to be the smallest black holes, is the smallest measure of this definition. However, no definite primordial black holes have been found yet. Luckily, in the 2019 paper, What if Planet I is a primordial black hole such that currently near the orbit of Neptune is maybe the black hole. There is a mysterious object that could be it. You may have a similar question to question 4. If there is such a black hole so close to Earth, wouldn't it suck in all the surrounding objects? According to the calculation of this paper, the mass of this large primordial black hole is only equal to a few times of Earth, not too big, and its volume is about the size of a tennis ball, really small. It would orbit the Sun normally like any other planet. It's too weak to make an effect. Therefore, Sheldon can do the experiment peaceful as the gold black hole is too small to make effect. Earth wouldn't be destroyed. It's worth mentioning that if this hypothesis is true, this black hole can be considered the ninth largest planet in the solar system. In addition, there are another three types of black holes based on their mass. Most of the one we observe most often are stellar black holes. When a massive star is dying, it cannot fight gravity, and eventually the core collapses fast into a singularity. The formation process releases energy from within the body to form a spectacular supernova explosion, like the picture I showed in the right. And we first talk about the ultra-small black holes, so there must also be supermassive black holes. Scientific name it as supermassive black holes, as we talked about. They can simply be thought of as the corpus of a massive star. These stars are between 100,000 to 100 million times the mass of the Sun. Objects revolve around a supermassive black hole. The Milky Way galaxy is around the famous star Sagittarius A, as we can see in the right side. Stellar black holes are no more than 100 times the mass of the Sun, while supermassive black holes are close to 100,000 times more massive. So, what is the middle 1,000 to 10,000 called? This is the intermediate mass black holes. Yet the typical intermediate mass black holes has never been discovered. Is it because we cannot find them, or are they just unable to form? This is still a mystery, and it also involves the theory of why black holes were born. These are still to be discovered by science, and we can accept that one day we will know that. Here is a conclusion. Today we talk about the definition of black hole, the definition, formation, evolution, and infection of the primordial black hole, and the other three types of black holes. Thanks a lot for listening, and this is my reference list.